Hi, Addy. Welcome to today's lesson. We are going to go over lesson number 55, and it is about complex fractions. It gets really complicated, so you're going to have to pay attention to this one. And then it's going to be easy. I think it's going to be pretty short, because then it's going to be division rule for complex fractions. So you'll learn what a complex fraction is and then how to divide them. I don't know why, I just think this makes me giggle. Like, it's just so funny. I don't know, would you buy fasteners from this area of the store? I just think it's pretty funny. All right, let's jump in. We're gonna do a quick review on the favorite rule that I like to say. So this is the denominator, numerator, same quantity rule. Say that 5 times fast. Okay, pause it right now. Say denominator, numerator, same quantity rule. I did it without even stuttering at all. It was awesome, and it's fun to say. So the denominator, numerator, same quantity rule, if you remember what that is, it means that if you have a fraction, you can multiply the denominator, the bottom part, and the numerator, the top part, by the same number, and you're not changing the value of the fraction. All right, I'm listening. Let's see this in action. Let's start here with the number 5, just the simple number 5. But of course, as you know, any number is a fraction. You can just put it over 1, right? So if we multiply the numerator and the denominator by the same quantity, so it would be something like this: 5 times 2 on the top times, I just got a text. I don't know if you can see those or not, but okay, 5 times 2 divided by 2. Okay, so what did I do here? I multiplied the top by a number and the bottom, which that was a fraction of 1, by the same number. So I'm basically just multiplying it by 1, because 2 over 2 is 1, right? So if you multiply anything by 1, the value doesn't change. But then I get a number of 10 over 2. And this fraction is the same as 5, which is what we started out with. It's another way to write the number 5. So you've changed the numeral, the numerator, and the whole numeral, I guess, but the number itself that it represents is not changed, just because that 2 over 2 has a value of 1. That's why you can multiply anything, the denominator and the numerator of a fraction, by any number. Oh, as long as that number is not 0. It can't be 0. 0 ruins the whole thing. 0 is a special number. And you don't change the value of the fraction. All right, so I think you get that. Denominator, numerator, denominator, same quantity rule. Okay. All right, now we move on to complex fractions. You're going to love this. I love the way your foul little mind works. All right, here we go. Complex fractions, all this means is it's a fraction on top of a fraction. Right? A fraction over a fraction. Okay, now, according to the rule that I said before, none of these numbers, like especially, I mean, the A could actually be 0, but let's not go there right now. As long as the B is not 0, because you can't divide anything by 0. And then you're still dividing any of these numbers by 0. So these also can't be 0. These 3 numbers cannot equal 0, or this whole thing goes to poop. So you don't want it to go to poop. We want to learn about complex fractions without it going to poop, right? So fractions of fractions are called complex fractions. And we're going to start in this lesson simplifying complex fractions. And we're going to do it by using the denominator, numerator, same quantity rule. All we do is multiply the numerator and the denominator by the same thing. So here, what are we going to do? All right, if we multiply, check this out, this is so cool. If we multiply the denominator of this complex fraction by its reciprocal, the reciprocal of the denominator. Remember what a reciprocal is? If you've got a fraction like 1 over 3, the reciprocal is 3 over 1. You flip it, right? If you multiply the denominator of this complex fraction by its reciprocal, you're going to obtain a product of 1. What does that mean? That means if you multiply this bottom part by d over c, now just look here, just look at this part. This reduces to the number 1, right? This cancels this cancels this. It would only be the number 1. Let's write it out so you can just make sure. C over D times D over C. If we only deal with this cancels, this cancel. It doesn't go to 0, right? It goes to something that looks like this. CD over DC, right? I mean, it cancels. And so it's 1. You're left with a fraction of 1, or a number of 1. Okay, so now that we know that we can do that, here we're going to multiply. Let's go back to this. We're going to multiply the denominator by its reciprocal. But of course, denominator, numerator, same quantity rule. Anything that you do to the denominator, you also have to do to the numerator. It has to be the same quantity, right? So we multiply the bottom by D over C. Let's multiply the top by D over C. Okay. If we do the math and multiply this out, what do we get? Okay, let's just simplify it for now. AD on the top, because you've got A times D. Whenever you multiply fractions, you just multiply straight across. And then we're going to multiply these straight across. The denominator's on the top, right? So it's going to be BC. Then you've got your fraction. Then we're going to multiply C times D, CD, over DC, which was these multiplied together to get that. Okay, we've done that. And we know that this part of the fraction simplifies to 1, right? Anything over 1 is just the thing. Like 5 over 1 is just 5. So this complicated fraction over 1 is just the complicated fraction. We can just get rid of that whole thing. So now we've taken a complex fraction, A over B, divided by C over D, and we get this easy thing. Okay, so we've simplified it. We simplified the original problem, and this is the step on how to do it. You multiply the top and the bottom by the reciprocal of the denominator. Okay, you're probably like, excuse me, I don't get this at all. That's okay. If we do it 3 more times, you're going to get it. Here we go. Let's do an example. We're going to do example 55.1. Here is the fraction. A over B, and then here's the complex part of the fraction, just divided by C. Now this doesn't seem as complicated as the other one, but it is. This is still a fraction over fraction, isn't it? I mean, you've got 2 fraction lines here. So if you've got 2 fraction lines, you've got a fraction over a fraction. Of course, we have the caveat that B or C cannot be equal to 0. So we're just going to set that aside for now. I just want you to know that that is a caveat, but we're just going to not do anything with that for now. Just know that in your head. All right, so what do we have to do? We have to multiply the top, the numerator, and the bottom, the denominator, by the reciprocal of the denominator. What's the reciprocal of just C? What's the reciprocal of just 5? You know what it is. The reciprocal is going to be 1 over 5, right? Okay, so we do the same thing here. This is not just a C, it's a C over 1. So what's the reciprocal of that? It is 1 over C. Denominator, numerator, same quantity rule. We're going to multiply the top by the same thing. This is just like multiplying by 1. You didn't change anything. You didn't change the value of the fraction. You're just simplifying. Now we multiply straight across, baby. A times 1 is A. B times C is BC. Multiply straight across. C times 1 is C. Straight across. 1 times C is C. Okay, now I'm gonna erase all of these non-important things. All right. Now, can we simplify this further? Of course we can, because look, C over C, what is C over C? What is any number over any number? Simplifies to 1. So I'm just going to erase that and put 1. But that can simplify even more. Anything over 1, I just said, anything over 1 is just that thing, right? So we can get rid of that, and this is our final answer. Bam! Did you see that? You take a fraction over a fraction, and you've got it, right? Are you feeling like this right now? You feeling like this? I'm sorry if you are. That's okay. That's because we need to do more examples. Let's do that again. That was fun. All right, here we've got a fraction over a fraction. That makes it a complex fraction. We've got 1 over c on top and 1 over b on the bottom. So let's start with the bottom. We always start with the denominator. The denominator is 1 over b. What's the reciprocal? B over 1. We're going to multiply that. Denominator, numerator, same quantity rule. Now let's do it to the top. Same thing. It has to be the same thing because you have to be multiplying it by 1. Of course. All right, now what do we do with fractions when we multiply? Just multiply straight across, baby. Numerator times numerator is just going to be b. This denominator times this denominator, c times 1 is c. Now a big fraction line. All right, 1 times b is b, and b times 1 is b. This simplifies to 1. Anything over itself is just a 1. This 1 is just redundant. You don't even need it. So this baby is the final answer. Look at how, this is so cool. This fraction simplified just to that. Oh, we made it so much more simpler. That was satisfying. Are you starting to feel brave now? You think you can do one? Let's do one. Let's do example 55.3. You can pause it. Try and do it ahead of me. See if you get the same answer as me. It's a challenge. Challenge accepted. Ooh, this one's tricky. This one is tricky. They're trying to trick us because here's the big fraction line of a fraction over a fraction. Here's the fraction of the denominator. Oh, okay. So the numerator is not a fraction. So is this really a fraction over a fraction? Oh, yes, it is. Yes, it is, baby. How do I know that? Because I see 2 fraction lines. You can't have 2 fraction lines. That's a complex fraction. Let's make it simpler. So what are we going to do with that a? We are going to move it up. Anything is a fraction, right? This is a over 1. It's a over 1 now. Let's start with the denominator. Now that we've got a fraction over a fraction, let's start with the bottom. All right, so 1 over c, what is the reciprocal of that? C over 1. C over 1, baby. And so that means I have to multiply the top, the numerator, by c over 1. All right, let me give myself, whoops, I'm sorry about that. Let me give myself a little more room. I just wanted to, whoops, got to bring that c. I don't want to leave that out. All right. What do we do with fractions when we're multiplying? We just multiply straight across, baby. 8 times c is ac. Oh, look at this. Check this out. 1 times 1 is just 1. Do I really need to write that? No, it's redundant. I'm just going to leave it off and just do my big fraction line. And then I'm going to do 1 times c, which is c. And then I'm going to do c times 1, which is c. I didn't even really need to do that, did I? I could just look at this area and be like, well, this cancels this and this cancels this, so I know the whole thing reduces to the number 1. And then I know I can just get rid of it. So bam, this is my final answer. AC. Oh yeah, that was great. Okay. I think we've got one more example in us, right? We've got one more example. How else could they trick us? Ooh, they could trick us like this. Check it out. They've got this whole thing on the bottom, on the denominator. No problem, no problem. It's still a fraction over a fraction. And we're going to go through the same method. Trust the method. All right, let's start with the denominator. Here's the denominator. What's going to be the reciprocal? Or what would I have to multiply this by in order to get the number 1? Now, it doesn't really matter if there's parentheses there. It doesn't really matter. But I'm going to do it without parentheses. So I'm going to do multiply by the reciprocal. Okay, a plus x on top and b on the bottom. Look at that. Now, check your work. If I multiply this part straight across, would it simplify to 1? Yes, it would. Yes, it would. All of that can cancel. It makes more sense to me with parentheses, but whatever, it doesn't matter. All right, denominator, numerator, same quantity rule. Whatever I did to the denominator, I got to do it to the top. So I'm just going to do that. A plus x over b. Multiply that. Okay. Now, this, I'm going to save myself some work because I already know that this cancels and this cancels, right? So all I'm going to do now is just multiply the top. This times this. Now, you have to be careful here because it's actually, the parentheses are helpful because it's not just, you can't, okay, I'm going to show you the wrong answer. I'm going to show you the wrong answer. What if I just did this? A times a plus x, and then it would be a squared plus x. No, that's the wrong answer. This is an entire quantity. It's a quantity. You have to keep a, you have to multiply a by everything over here. You have to also multiply it by the x. So this would end up being, if you multiplied it out, a squared plus ax. Right, that's why the parentheses are important. You would get the wrong answer if you didn't do that. All right, let's move on. Denominator, multiply those straight across and write the answer there. It's going to be xb. Yeah, now that's the right answer. And I don't need to do anything on the bottom because it's all going to be over 1. I am learning at this point to make it a little more simple. That's my final answer. Yeah, we got it. Okay, now, are you ready to make this a rule? Because we've been going through the process, so I think you understand now the process. But guess what? You've probably learned this before, the division rule for complex fractions. Or think about it as dividing fractions. What do you do when you divide fractions? To divide one fraction by another fraction, invert, that means do the reciprocal, invert the fraction in the denominator, and then just multiply straight across. That's it. Is any of that ringing a bell? Yes, you've done that before. You totally have. Now let's practice it with variables, these variables, and let's see. Let's just use that rule and make it easier. They showed us in the book the process of why the rule works. Because it's the denominator, numerator, same quantity rule. If you multiply the top and bottom by the same thing. They don't teach you that in school. No way, they don't teach you that. All they teach you is, if you're dividing fractions, invert the second one and multiply straight across. But you're like, why? Why does that make any sense? It doesn't make any sense to make the denominator upside down and then multiply. Why does that make any sense? Now you know. Now you know. Now you're smarter than all of these people that learned this in regular school, and probably the teachers too, because this is how it's done and why it's done, okay? So here we go. Let's look at this example. We've got a fraction over a fraction, several fraction lines, right? So that makes this a complex fraction. Let's just use the rule to figure this out. The rule says if you're dividing fractions, because that's what we're doing, right? This is the same as, well, let me do it. Yeah, it's the same as dividing x over y, right? It's the same. What do you do when you divide fractions? You invert the second one. That means you take this, okay, see how I move, and then you multiply straight across, and you get my over nx. That would have been cool if we spelled a little secret message, right? So this would be the answer, right? Okay, now if we go through that process that we just did earlier, mn divided by xy, we multiply the denominator by its reciprocal, the top by the same thing, and you get my over nx. All of this reduces to 1, and so you get the same answer. And that's why that rule that you've always learned and always been taught works, because now you know the process. Okay, get it? All right, here are the basic rules of algebra that explains some of these weird things that you've been learning in school, but it explains it. Almost all of the things that we do in algebra can be explained by these three simple rules. The first one is the denominator, numerator, same quantity rule, which we just went over. The second one is the multiplicative property of equality. That means if you've got like an equation, you can multiply this side of the equation by something and this side of the equation by something. You didn't change the value. It's the same. The additive property of equality, that's the same kind of thing. You've got let's say you've got an equation, right? You add something to both sides. Yeah, you can do that. You didn't change the value of anything. So those are the rules of algebra, okay? Are you so happy and excited about that? Ecstatic, right? Love you, Addy. Have a great day. Bye.